solutions engineer here with Strayos. And today we're bringing you the application of drones and AI in the UK Quarry environment and operations. Adrian's here to join me, and I'll let him introduce himself here in the next slide. Unfortunately, Matteo was unable to join us today in the webinar due to illness. However, he sends his regards, and he's happy to answer any questions if anyone wants to reach out with him regarding information with Strayos as a platform. So with that said, Adrian, I'll turn it over to you for introduction, and we'll move on from there.
Thank you very much, Elijah. Got the next screen, Elijah.
There we go.
Yep. Okay, a little bit about London Minerals Consulting Limited. I formed it in 2004. I was formerly a quarry and geologist for Tarmac, and I set the company up as a geological, geotechnical and survey consultancy, mainly to the UK quarrying industry. We adopted a trading name of Quarry Design in 2006 as that better reflected the work that we were doing. And we invested in our first long range, i.e. 2 kilometre plus LiDAR in 2010 as a safe system of work for obtaining fracture mapping information rather than using a compass clinometer. In 2012, at the end of 2012, we invested in our first multi-rotor drone, and we got licensed in June 2013 with the CAA with a UAS number of just 244. We adopted a second trading name of DroneServe in 2013, mainly because London Minerals and Quarry Design doesn't always go well when you're doing large-scale environmental mapping of coastal cliffs or mountainous areas. And we won a prestigious Minerals Products Association Safety Award for bringing drones to the UK quarrying industry in December 2013. We bought our first vertical takeoff and landing drone from Quantum Systems in 2017, their Trinity drone, and we're now their UK reseller. And it's through Quantum Systems that I was introduced to Strayos. Strayos had recognized that the Trinity drone with its 5-way oblique camera was a perfect mapping tool for their AI software. We're now a leading provider of remote survey acquisition and geological and geotechnical mapping, interpretation and analysis to the UK quarry industry. And we have a 1 kilometre standing VLOS and 2 kilometres beyond visual line of sight operational authorization for our Trinity drone. And we've also worked worldwide. And with that, I'll hand back over to Elijah to explain why it is that Strayos particularly suits the UK quarry industry and why I think we're perfect partners to distribute their AI software.
Awesome. I appreciate it, Adrian. And it's great to hear a little bit about London Minerals Consulting and your operations and tie Strayos into those. So I'm happy to present for Strayos here a little bit about the company in the background and what we really are as a software. Strayos is present in more than 30 countries with over 3,000 mines and quarries where we are providing service in our solutions. Our team does have a global presence here in North America, headquartered in Buffalo and also St. Louis. Myself, I'm located in Colorado. Well, we also have our team supporting in Europe and also Asia and India. So with that being said, what is Strayos and how is it fulfilling the value chain? And Strayos is really a one-stop shop software for its internal photogrammetry as far as its value chain of processing information. And at its core, Strayos is its own photogrammetry engine where we can process imagery in data sets, pre-processed models to perform a lot of different tasks within the same software. That really starts with the survey and the planning, moving through geology analysis, drill and blast, loading and hauling analysis, as well as processing post-blast analysis, as well as stockpiling and reporting all of these modules, together through a lot of automated reporting features. So for the end user, it really starts with the data capture. So the workflows are essentially going to remain the same for the end users, and that's flying the drone, capturing the data, processing it using photogrammetry, and then bringing those into, let's say, third-party solutions such as CAD-based softwares. However, now with Strayos, this can all be done within one software. So instead of processing photogrammetry in an external software and bringing to third-party softwares, it can all be done within one. So here, again, the data capture can be carried out, uploaded to Strayos' cloud-based platform, where we can process using our own photogrammetry and our AI modules to get more value out of one software. Again, a lot of the outputs of Strayos can still be brought into third-party solutions for further analysis. However, the photogrammetry processing and the analysis that can be ran in Strayos brings more value to that data capture that's being done. So with that being said, we're going to transition into some of the modules and the AI features within Strayos, really where this value comes from. And we're going to look at some use cases, specifically in the quarrying and the mining environments, starting with inventory management. And you can see as we work down the list here, we'll touch on several topics where it really ties into those direct operations that Adrian mentioned. So beginning with the inventory analysis. So Strayos really incorporates its AI in stockpile detection and applying this to the site and the data that's being flown. So this is going to really cut back on the surveying costs of these piles, where a drone flight can capture the data much faster than a standard survey crew. And we apply AI to this with the auto detection of these stockpiles, where users can then apply their material databases to those piles to achieve volumes, tonnages, prices of the materials they have on their site. Now, this serves as a direct workflow, whether the surveys are being conducted daily, weekly, monthly. There are dashboarding features here where these materials can be tracked on that frequency basis. Again, you the AI to really cut back the time of the survey cost in the analysis of quantifying these materials. Now, we can also apply this to some monitoring of inventory on site. So yes, we can monitor the stockpiles and volumes, but also if we're doing some short to mid-range pit planning, really monitoring how much material is being mined or removed from the site, whether that's through a stripping operation or monitoring material that's been quarried or mined at different level of benches. There's multiple ways where we can run this analysis in Strayos to quantify, that pit progression over time and convert it inventory management. We also have an API integration with SAP. It's important to mention where we can push this data reported from Strayos. Again, feel free to reach out to our team for more information regarding this. Did want to mention it here in the beginning with that reporting function. So moving forward to our haul road assessment, I just want to take a pause here. Adrian, everything sounding clear and presenting well?
Yeah, that's. I think that's fine. There was just one query where someone said that they just saw the Strayos logo and not the slides, but that only appears to be happening for the one person, Joe. I've just checked with Mike Williams, and his screen's okay, and Mark Little from Tarmax just confirmed that he's seeing it all okay as well.
Okay, great. We'll keep moving forward then. Our next example we're going to talk about is the haul road assessment in progress. So another area where we can apply AI is analyzing the haul roads on the site. Now, what happens here is, once the data is captured and uploaded and processed in the Strayos program, there's an AI module where we can run detection of the haul road. And that's what we can see on the images here on the right side, where the center line of the haul roads are detected, where then we can show things such as grades, crossfalls, road widths, or berm heights of those haul roads automatically. Now, there's a direct benefit and value here where you're getting all this information from that drone flight that you are capturing from the original data. So there's no need to do additional manual surveys for this information. You're essentially getting all the value from that drone flight itself. Now, this information can also be reported and export it in different file formats such as DXFs or CSVs to bring in to third-party solutions. But overall, the benefit of monitoring these haul roads, is really coming into the compliance and looking at safety, fuel, how these trucks are running on these sometimes larger, lengthy sections of haul road, where grade changes can have a direct effect on the equipment wear and tear and fuel costs. I did mention the progress reporting. So looking at certain aspects of these haul roads here. So certain cross sections can be drawn or traced where we can report more granular sections of, let's say, grade or road width of areas that we want to further report. You can see the KPIs are on the bottom there, and we can copy these areas of interest, I'll say, from project to project. So if there's sections of haul road that are looking to be analyzed, over a time span, if it's under development or if improvements have to be made, those can be monitored flight by flight. Now, I mentioned the reporting as well being completely automated. So with the function of the haul road, as well as some of the other modules we'll cover in Strayos, these automated reports are going to provide the information that can then be shared directly with team members with a PDF or a share link for further reporting and analysis. So what we can see here, just a snippet of one of the haul road reports where there's an area of interest that has been drawn, showing the grade, the crossfall, road width, and berm height in the thresholds that have been set by the user. So with this automated reporting, really streamlines the workflow for customers to report, what these surveys are producing and what areas may need improvement, may need to be addressed, at a very direct pace here. So with the haul road modules of the Strayos is a case study here that we wanted to share where a certain mine customer was started and began to monitor these haul roads, which really ended up in a direct savings of, you can see here, savings of 27% for the transportation of 10 million tons of material. Looking at the crossfall management as well, after precipitation events, rain, snow, whatever it may be, runoff, monitoring this condition really helped improve the condition of the road with less maintenance or understanding where the maintenance needs to be addressed, saving in the diesel costs. So, just one example here, kind of overviewing one larger case study. We're happy to share some of these metrics on how that value can be saved from monitoring things such as the haul roads. To summarize, the up-to-date haul road assessment, can help really improve cycle times when you're looking at haul routes, conditions of those roads, wear and tear of especially fuel costs, and essentially helping improve safety. Any road incidents, looking at traffic patterns on some larger sites where haul roads might have a more intricate network. All these points can be looked at and derived from the haul road planning and analysis within Strayos. So moving along to the high wall and slope safety geotechnical analysis. So another area where we can apply AI to really shorten the workflow that has been done traditionally in a more manual state in the past. So with that being said, Strayos has the capabilities of detecting the crest and toe automatically within the site. Based on that crest and toe detection, we can then derive things such as the high wall heights, the face angles and ramp angles, catch bench widths of the site itself. So on the images on the right-hand side of the screen, you can see the face angles on the top, as well as some cross sections that are drawn on the bottom. Now, users have the options to set different thresholds here, report certain areas similar to the haul road, where we can analyze this data bench by bench, maybe area of the quarry, to really look at, what could be out of compliance, within compliance, where we could be seeing that geology change within the site and how that's reflecting on the physical characteristics of the site here. Specifically looking at the cross sections on the bottom here, we can see those sections that are highlighted on the bottom there where that inter-ramp angle is shown, as well as the distance and the elevation profile. So with the direct benefit of having this tool, it really cuts down on the time of manual surveying, and you're getting this information again out of that one drone flight that's been done in the pit. Now, looking at the benefit of doing that, really running on compliance and safety, where we can constantly monitor these conditions based on the frequency of the drone flight. So we can see a 3D model now shown on the screen here. And this is really going to allow us to look at the data both in 2D and 3D. The picture on the right here is showing a snippet of the 2D where that crest and toe analysis is being ran and some areas of interest that I want to share. What that is going to look at specifically on a statistical basis. So here, based on the graphs on the bottom, as well as the cross section on the top, we can see the metrics such as the high wall heights, angles, catch bench width, and inner ramp angle. These features can be also exported, such as the cross section, as a DXF to third-party softwares for further analysis and planning. So again, with the reporting, I do want to share a little snippet here with the automated reporting on the high wall analysis. Based on the crest and toe detection, again, we can look at these metrics that are being derived, such as the heights, face angles, catch bench widths, and inner ramp angles. This can all be compiled into that report that can be shared with team members via PDF or share links. It's going to give a good breakdown of each of these metrics and the area of interest that is looking to be reported. In this case here, on that cover page, we can see the green area that's highlighting that one bench. So another critical aspect I like to point out here with monitoring is the capabilities of uploading a pit plan, a mine or quarry plan, surface file, Strayos to overlay to your drone model. Now, again, taking the value of that one drone flight, what we can do is upload and overlay that surface file to look at conformance. And this is, in this example here, looking at overbreak and underbreak, actual versus design, and really giving us a good image of pit progress, pit wall conformance, looking at the geotechnical model, structural model, how the drill and blast designs could be overperforming and underperforming. In this case here, red is overbreak and the blue is showing underbreak in the pit. And this can be done very easily in the Strayos platform, where with these surface files, we can upload an overlay to the drone model to visualize these metrics. We can also apply AI to rock mass detection, and that's going to automatically detect discontinuities within the rock mass, whether that's bedding planes, faults, joints, seams in the rock face. In the example here, we can see a stereo net on the right, as well as the model on the left, which is showing some specific, some more horizontal bedding planes there with the dip direction, the strike direction, and the dip angle. This is all based on the AI findings. And again, these can be exported in DXF or CSV formats for further analysis in, let's say, third-party softwares. It is important to mention tools like this, they're very valuable, and the data that we input for such analysis requires, good accurate imagery with low GSD and some oblique imagery of the face. With that high quality imagery gives the best yield of results for this AI detection. So just an important note here I want to share, we want to get the best quality imagery possible for such data output, such as the AI detection of these continuities. So what's the value in these up-to-date high wall assessments? This is providing direct information on our site and the geologic conditions on the site, specifically looking, at safety and where we can look at potential high wall failure areas, looking at slope analysis, specifically, where we could be seeing changes, whether it's weather events, freeze thaw cycles, how these high walls are changing, where we're seeing commonalities in the high walls. We can take a lot of information from these drone surveys um, to compile and compare, over time and how to monitor these conditions. Preventing rework or loss, these go along with that as well. So, looking at the pit progress and conformance. So, we talked about overlaying some of those design data sets to our, as we'll call them, as built conditions or the surveyed conditions. Now, with this, we can really monitor volumes, measure mine reserves, identify areas of non-compliance, look at cut fill quantities in several layers, such as elevation models and contours. Now, this is kind of a lot of information to unpack in one slide, but what I really want to highlight here is, I've been mentioning out of this one drone flight, we can really accomplish many tools and extract a lot of value using a lot of these modules. Um, Specifically looking at, when we compare these surfaces and monitoring, let's say, cut fill quantities, whether you're flying your site, let's say at the beginning of the month and the end of the month, or maybe on a weekly basis or even a daily basis, we can monitor these cut fill quantities, whether again if it may be a stripping operation or drilling and blasting operations. We can run that analysis within Strayos and also overlay different layering if we want to compare contours, elevation models, or those surface files in the XF to identify areas of non-compliance. Again, the reporting function, we looked at some reports with the haul road and the high wall. It's automated, and you'll see these automated reports in modules such as the cut fill and the elevation exports as well. And this really serves the benefit to the user where, you could bring in your drill and blast team to work alongside maybe your quarry planner, quarry engineer to really make sure operations are running smoothly based on the drone data capture that's being done to report these. So, talking about mine planning and pit development, we don't really like to say Strayos is a mine planning software. We like to use it and help customers the short and midterm planning process, whether that's reporting quantities, breaking out volumes and kind of staging the pit and forecasting its operations. With that being said, the capabilities of overlaying, complete design plans, we can see on the upper left-hand corner there, as well as, running cut fill analysis and really breaking out volumes and, areas of interest where, work is to be done. We can see on the bottom left-hand corner there, allows us to follow that mine plan with the aerial data that we are capturing. This can really help, I'd say, improve the pit development and maintain the operation that's being done by monitoring these conditions. As I mentioned, monitoring, grades, elevations, haul road conditions, all these physical characteristics that, can slow down the operation, can be monitored and I would say kept ahead with to make sure operations run smoothly on a daily basis. Last example here I'll talk on is drill and blast. Strayos has a robust drill and blast suite of tools where users can create a drill design or bring in, let's say, a drill design that has been done maybe in a third-party software. With that design, that can then be exported to a GPS or maybe a GPS-equipped drill. That can then be used to lay out the design properly based on the model that's been formed by the drone data capture. Within Strayos, we can export, again, this information to the drill, but also bring information from the drill to really close that drilling cycle. So this really does start with the drone data capture, flying the bench that's going to be drilled and eventually shot. If that's utilizing a GCP workflow, maybe an RTK drone or PPK processing to get the absolute accuracy of that model down to, let's say, a centimeter grade level precision to make sure that information relays to the GPS properly and you're getting the most accurate layout you possibly can. Executing this design. So within Strayos, designing these shots, you can really dial in the proper burden and spacing of your blast for proper layout purposes. Based on that design, we can then load and time our blasts appropriately using optimization features. Um, in this example, we can see a couple timing diagrams on the bottom showing the angle of initiation as well as the burden relief, in the millisecond per meter or per foot, depending on the units you're working in. And we can really properly load these boreholes based on the condition on the site, the products that are being used, and optimize the timing to adjust, let's say, the throw direction, where we might want to open that shot, or address any vibration concerns. This can all be done within the loading and the timing of the drill design Strayos. Talking a little more about drill control, I did mention it before. This Strayos has the capabilities to export these drill designs and the information to the drills equipped with GPS or smart drill capabilities. We pull that information from the drill. So in this case here, looking at a post-drill workflow, once that design is completed, the shot has been drilled. Again, bore tracking. Bore tracking is a method of measuring the deviation, inclination of the boreholes. We can accommodate that data into Strayos as well, providing burden reports and also drill plans post-drill. So with this workflow here, really getting the accuracy of laying out the shots properly, sending that to the drill to be drilled, minimizing drilling costs, extra holes that may have been drilled, drilling to proper grades. There's a lot of value that can come from utilizing this workflow. Drilling face holes to the correct burden and also measuring that with any bore tracking that is being done on site can really ensure the safety of the loading process when shooting an open face in close proximity to any structures. This again, utilized all in one software is really where the value is going to stem from. One of the unique AI features I want to touch on with the post-drill workflow is the hole caller AI detection. So what we're looking at here in the image is the AI detected boreholes that have been drilled. Now, Strayos has the capabilities to overlay a design to that AI detection where we can see, in this example, the red holes are out of the threshold of deviation based on the design. So depending on what that threshold is, maybe it's a half a meter, maybe it's 1 meter or exceeding. This is telling us that that hole was drilled outside of that design threshold. And this is a good quality control check where, maybe the driller, couldn't approach that crest as close as it was originally planned. Maybe where seams or voids in areas, where that's going to start deviating the hole position. This is going to help us run a quality control check. And we can see on the bullseye diagram on the left, kind of where those holes are falling into place based on the accuracy. Going along with this is our floor control. And this is going to allow us to analyze the floor of our pit or quarry and overlay drill designs to that to show any, let's say, high or low spots. Now, this can be ran as just based on the drone model that has been attained. We can also apply a DXF surface to compare design to this. However, the value that's going to come out of this is analyzing, again, the higher low spots in the floor. And if that came from digging out, let's say, sub-drill, or let's say a bench wasn't drilled to the correct elevation, we can really look back and overlay these drill designs, as you can see in the bottom right-hand of the image, right-hand side of the image there, to what shots or even what holes may have correlated to those issues. In that image as well, you can see the green areas are, right on grade to that set elevation of about a meter, 3.87 meters, excuse me, where the red area starts approaching 8 meters below, and the blue area is about 8 meters over. So pretty big elevation change there in this example, but you can really fine tune this to a meter or a sub-meter level to look at, the smaller granular changes in the floor based on let's say, the drilling and blasting operation. Again, this is going to serve, let's say, in the loading and the hauling, the smoother the floor, the smoother the operation. If you start seeing higher low spots, this can really help you address where those grade changes could be occurring, whether it is from the, let's say, the drilling or the loading and hauling process. We can see here in the little pop-up, the D&B operations can generate uneven floors. I'm sure we've all seen, high bottom or, digging out sub-drill in some cases. Really addressing these problems right off the bat will serve the operation moving forward in production. Another real example, kind of more of a case study here, analyzing the post-drill condition versus the design, can really kind of look at potential, let's say, fly rock areas or maybe even cut off potential if holes are too close to one another, how we're going to adjust our timing or our loading practices based on those conditions. If you have the luxury of flying these benches pre-blast but post-drill, you can look at those design changes before showing up the day of the shot, where you could be, making some critical decisions in a short amount of time. This allows explosives engineers, blasting engineers to really look at their as drill designs before showing up that morning to blast and making those changes to maybe their loading and timing plan that they had. Lastly, with the drill and blast process here is the fragmentation topic. And where we can apply AI to this is the automated detection of the muck pile post-blast. And Strayos can run predictions and also analyze the post-blast muck pile, to report the fragmentation results. Now, this can be done, again, with the drill design that's been accomplished through Strayos. You'll achieve the prediction, as we can see on the right-hand side here, with the distributions that are shown in the distribution curve, the parameters that are shown on the left-hand side. And then on the left-hand side of the AI measurement, this is showing the post-blast muck pile, where we can run the post-blast analysis and report those actual fragmentation measurements based on the AI. Again, a valuable tool to use to really analyze that post-blast result and look back to address any design changes. If there's excess oversize that has been seen on the site or excess fines, really start to adjust that drill design to achieve the optimal outcome that's being looked for on the site. This can also be applied to the muck pile as well, where we can look at a full cast analysis of that muck pile, looking at elevation profiles, the center movement, average height, maximum throw, average throw of that muck pile, to really look at the blast performance, whether we need to maybe speed up our shot a little bit timing wise, maybe slow it down, depending on the operation, if it's a loader based operation or excavator based digging operation, how we want that muck pile profile to cast to optimize the digging. Again, this can be done just with the drone flight post-blast to look at that muck pile boundary, tie it to the pre-blast project, and we can look at this analysis to make better predictions in the future, but also optimize our operation to get the best production from the blast itself. So to summarize the D&B quality control, really what Strayos is helping here with is optimizing these designs to improve the diggability and crushing rates on site. Drilling is the main cost here, as if we can help reduce the drilling costs, reduce excess holes, excess drilling, that's really going to be the bottom line cost savings there, essentially reducing the overall drill and blast costs. Big safety factor comes into this as well, making sure patterns are designed properly with appropriate burdens, to really, get the best out of our drill and blast operation. Again, tying back to the improving the diggability and crushing rates and throughputs on our sites. So I'll conclude my side of the presentation here. We encourage you all to book a demo, reach out to Adrian. Happy to help here with any further questions regarding the Strayos side as well. Feel free to reach out to myself and Mateo. Adrian, I'll hand it over to you for any last closing comments here before we answer any potential questions.
Yeah, I think as a quarry geologist, a lot of what your software does, I was doing individually via multiple pieces of software. So to have all of this in one place that really starts with that drone survey and then allows all of this analysis to come afterwards is where I see that, you know, the benefit. For the people that are listening, we've been working with Strayos for quite a bit before we made the announcement. Our geotechnical engineer Alice Kingman has been doing lots of checking against, say, the fracture mapping with what we were doing with split FX and dips. And we've also been checking some of the volumetrics against LSS, so that we've been doing our own quality control before we got to this point. And I think it's the first piece of software that brings together all the specialists in our industry together. Whereas before there was a surveyor going out, he'd pass the data on to the geologist who would do the block modeling, the geological modeling, pass it on to the geotech would put the feedback into it. And then the quarry manager would get hold of it. He'd do whatever he needs to do. Your stock surveys can come out. This brings it all together as like a collaborative online platform. I think that's where its strength really lies. So I think that in summary is why we've made this presentation to you and why we've formed this partnership with Strayos.